Tashidale once again. I'm Tenzu Wonga, and I'm going to continue from the part we had done yesterday. So yesterday we were discussing about distance, displacement, motion, and all of this. And yesterday I'm yet to finish with the whole portion of displacement. So which is why today our learning outcome will be displacement, vector quantity, uniform and non-uniform motion. So let us proceed. So yesterday I had already mentioned that displacement is another kind of distance where we are concerned with initial and final position. We are not concerned about where a particular person is going to travel. For example, this might be the road, and this may be 5 kilometers, 7 kilometers, 8 kilometers, 9 or 10, whatever it may be. We are not concerned about the pathway in which he was traveling, but we are more concerned about the initial position, that is the starting position, and the final position where he is, and the distance between these two is what we used to refer as displacement. And generally there is a direction involved in that, right? Okay, so today we will talk a little more on displacement. That yesterday I said displacement can be positive, displacement can be negative, and displacement can be zero, right? Okay, so now I'm talking about the positive sign in the case of displacement. So as we have already discussed that displacement is another kind of distance, so we shall say that a person, this is a person here, if he is covering a distance of 5 meters to this region over here, this is his initial position here, and this is his final position here. So to cover this area over here from A to this position to that position is 5 meters. So you can somehow say this is also the distance and this is also the displacement, which is coming in the form of positive values. Now talking in terms of displacement in the case of zero over here, that is zero displacement. So zero kind of displacement occurs, okay, when initial and the final position are at the same place. For example, okay, a person is traveling from Chandigarh. This is the capital of the Punjab, or you can say Haryana, or all of this, right? And a person is traveling from Chandigarh to Delhi. So you can say from here to there, from Chandigarh to Delhi is like 250 kilometers, right? So a person travels from Chandigarh to Delhi, but he came back from Delhi to Chandigarh the same day. So his initial position is over here and his final position is back over here at Chandigarh. So you can somehow say the distance traveled by this person could be 500 kilometers. But what about the displacement? Since his initial position is over here and his final position is over here, we can somehow conclude here that the displacement traveled by this person is zero. Similarly, there is another cases over here. For example, this is the Earth, and we have so many different kinds of satellites up in the space, right? And this satellite, they used to revolve around the Earth, thereby giving so many kind of information to us. Now this is the starting position, that is the initial position. If a satellite gives one total revolution around the Earth, his final position will be over here. That means his initial position and final position both are at the same place. We call this kind of displacement as zero. Why? Because initial and final are at the same place. Understand? Now talking about displacement negative over here, I'm going to write one small graph here. Okay? So this is 0. This is -3, -2, -1, 0, 1, 2, 3. Okay, so this is north, this is east, west, south. Okay, now there is a person standing over here at 0. This person travels 3 meters and he came over here. From 0 to 3, this value is positive, that is the displacement is positive. Now this person again came back to his own original position over here. In the second case, displacement is 0. Why? Because he is over here, started from here, and he goes over there and came back over here, 0. But if that person travels in this region over here, that means he is moving in an opposite direction there. Because over here I have labeled it east, and over here I have labeled it as west. So generally, displacement, whether you call this as positive or negative, displacement positive and negative is defined on the basis of the change in the direction. Whenever there is a change in the direction, we call this kind of situation as negative kind of displacement. Is that clear? So this is how we are going to go for it. Understand? So now, yesterday, in the case of distance, we talked about magnitude. That if a person is covering 200 meters, there is we don't have any kind of idea about where he is traveling, because we don't have any idea. Now in the case of displacement, I used to say something like a person is covering a displacement of 200 meters towards the north. That means I'm giving you a clear information right now where he is moving, that is towards the north. So a dog is covering a displacement of 300 meters towards the south. So I'm giving you a displacement over here, displacement, magnitude, as well as direction. So that kind of situation is what we used to call as vector quantity. This is another kind of quantity. Yes, vector. Vector quantity. This is a physical quantity in which there is the presence of magnitude. Magnitude is present. Along with magnitude, the direction is also present. Understand? Magnitude and direction both are present, and its example is, that is displacement. Displacement. Understand? Displacement. And I can give you another example. This is a table, and there's a person. He is pushing this table by using his force of 10 Newton. Now, looking at this diagram over here, you can somehow identify, okay, you can somehow make out how much amount of force he is applying, how much. That is the 10 Newton, that is the magnitude. And in which direction he is pulling? Is it in that direction? No, it's in this direction. So any kind of physical quantity where there is a presence of magnitude and direction both, they belongs to vector quantity. Clear? Okay. So now motion can be generally classified, not actually classified, but we can somehow like divide into uniform motion and non-uniform motion. And it is very important for all of us to feel that we witness this kind of thing here, uniform motion and non-uniform motion in our everyday life. For example, we are more used to non-uniform kind of motion, but we also see a uniform kind of motion in our life too, right? So now what is uniform motion? Uniform motion is a motion per se. It's important for us to know that it's a motion. And this motion should be in a very uniform way. Should be in a very uniform way. Right? For example, students are asked to wear uniforms. Why uniform? To have a similar kind of outlook, right? Because if you all started to wear your own clothes, there will be many kind of different cases coming up. some students, they won't be able to wear good clothes, and some will be able to wear good clothes. There are like so many kind of issues coming up. But if you are wearing uniform, that means all are same somehow. So somehow you have to imagine that whenever we are talking about uniform motion, there is something like a same thing, right? Similar. So let us talk uniform motion. Let's suppose, imagine, okay, there is a car. Okay, this car is moving. This car is moving. Okay, this car is moving, and this car is moving. Let's give this time in minute, distance in meter. Let's suppose, imagine, in 1 minute, this particular car covers 10 meters. In the next minute, that is 2, it covers 20 meters, sorry. In 3 minutes, 30 meters. In 4 minutes, 40 meters. What do you see? What is the difference between 1 and 2? 1, that means 1 minute. 2 and 3, again 1 minute. 3 and 4, again 1 minute. Right? So over here you see the similar kind of thing here, 1, 1, 1, 1. And over here also you see 10, 10, you see 10. So that means the fluctuation, the change in the distance and the change in the time is somewhat same, going in the same way. So when you plot the graph, this is not the non-uniform motion. We will talk about non-uniform motion in the next one, okay? Yeah, so I'm going to write the distance in that manner here. This S symbolizes distance, right? Okay, this is 10, 20, and 30, 40. Now this is time. This is 1, 2, 3, and 4. 1, 2, 3, 4. Okay? So in 1 minute it is traveling 10 meters. In 2 minutes it is traveling 20 minutes. In 3, 30, 4, 40. What you will come to know is that when you join all of this, when you join all of this, you will get a straight kind of graph. Whenever you get a straight kind of graph, we call this kind of motion as uniform motion. Understand? And how we define uniform motion? When an object covers equal distance, that is 10, 10, 10, equal distance, in equal interval of time, that is 1 minute, 1 minute, 1 minute. When an object covers equal distance in equal interval of time. This kind of motion is referred to as uniform motion. I will give you one example. Okay, the one example is fan. Whenever we are like switching on the fan, okay, we see number 1, 2, 3, 4. Okay, suppose if you want to put the fan on number 2, that means if you put the fan on number 2, the blade of the fans, they will move at the same kind of speed, right? Same kind of speed, unless and until you increase to number 3. This kind of motion there, uniform motion. For example, on a plain kind of highway, let's suppose on a plain kind of highway here, straight highway, where this particular car, if this car covers 10 meters in 1 minute, then it covers another 10 minutes in 1 minute, then it covers another 10 minutes in 1 minute, we call this kind of motion as uniform motion. Understood? Now let's go for the non-uniform motion there. It's just the exact opposite of what we have done right now, right? Okay. So non-uniform motion. what we do normally in our life, right? For example, okay, there is a highway and there's a school, and in front of the school there's a speed breaker, right? So now you are riding a bike here. This is a person, okay, he's riding a bike, and he's covering some amount of distance, right? And he's also coming at some amount of like speed or so, velocity and whatever it may be, right? Now, the moment he reaches to this point over here, he has to reduce his speed. Otherwise, there is a big possibility that he might fall down. So, he has to reduce. The moment he crosses this speed breaker, he will once again increase his speed. So, there is a change. Over here, there is an increase, there is a decrease, then there is an increase. So, these kind of motion, normally, okay, like we used to call this uniform speed, but we are talking about non-uniform motion. That means here, distance. We measure in meter, and time. One, two, three, 4. Right? In 1 minute, this particular car or whatever the bike covers a distance of 10 meters. In next minute, what he did, 15 meters. In the next minute, he took like 30 meters. In the next one, he took, let's say, 60 meters. Now here, there is an equal interval, 1, 1, 1. That is 1 minute each. But over here, there is a 5 meter. And over here, there is a 15 meter. And over here, there is 20 meter. Now, this is not same. This is not same. So, when an object covers unequal distance in equal interval of time, we call this as non-uniform motion. Suppose if I write the graph on top here, that is, let's say, this is distance. We are going to measure in 10, 20, 30, 40, 50, and let's say this is 60. And all of this should be in meter. And time is like 1, 2, 3, and 4. Okay, so in 1 minute, this particular bike is traveling 10 meter. Oh, sorry, 10 meter here. In the next minute, it's covering 15. Let's say 10, 15 could be somewhere in between, right? Okay. In the next minute, 3 covers 30. Okay. In the next minute, that is 4, it covers 60. Here. Now, if you look at the graph, if we join, okay? Are we getting a straight kind of graph? No. Here, this is this kind of graph here. We get this kind of graph here. This is the kind of graph where an object covers unequal distance. In equal interval of time. This is what we call as non-uniform motion. Okay? So, I hope you have understood about displacement, vector quantity, uniform motion, and non-uniform motion. That's all. During the displacement check, vector quantity check, uniform motion, and non-uniform motion. Chidang displacement positive, negative, and 0 and chassis. Positive distance that you can kissing near my demand give the combat 5 meter covered Shibana, initial part and final delay, and running for distance 5 meter in the Kadina value deposited and leaders. Wow. Tama daily and you have a Jachimbaina, you starting daily and ending in Dechibaina, displacement is 0 days. Wow. Tama starting Dechide, parching the Sudere, and you parching by now, direction Chiwayasos, Kajini, near the east ratio, Tama west Chingsons. So, Katina, direction Chiwayabaina, displacement Kadina, negative challenges. Wow. This year, Tadija vector quantity legs or vector quantity, Chidang, physical quantity near your shore, check the scalar quantity re, check the vector quantity re. Vector quantity na keja kharch hola na ki kadina direction the magnitude ni ga go re la pena ni da kana so example force chagu ni kisi ha force pha gya bai na pha gya bai ni magnitude ki force the let's say 30 newton ni bai na ni 30 newton the kharch ho re ni magnitude cha ho re ni ni ki force apply che direction the cover pha is so then ala ni ki direction ta ni ga ting dos wa dinde chela ma so khala re vector quantity la re ani ni la kana so la ba na shi a person is applying a force of 20 newton towards the east. Direction a person is a dog is covering a displacement of 5 meters towards the west. That magnitude the vector quantity. Uniform the non-uniform motion ada maza kita nam ke ngara se life na thoshim chide. Pena uniform rochina maza ke pena the highway khadu china bus the travel no bus na tudiwa. Bus na tudiwa chitangi chok soch khari yola na uniform motion dizala mid zege mangche ni shwe da the possibility pe awar. Non-uniform motion na chingba na mid zege ta shimela da le or pena bus chik ngaz nakal tang de ki man break gap yang gone do yang break gap gone mi supu de thuja de ni ani shimela da le dwa ta uniform motion khane chla wala na kisi ngobu chala chi gi distance cover dirwa pena time minute chik na ku 10 ina next minute chik na 10 yang next minute na 10 dinte cover chik na the uniform motion na so khadina graph de kale khatu go ravis distance the time the graph de khatu ravis wa ta non uniform motion na ching na ta ngara se everyday life na ani de such de la ani turn the de ani so kola kya bya ma door wa de so de ma speed new ta gore ya ma door graph de khatu lig mare to de lig is dinte chik na so ki non uniform motion na gore that's all. So I shall see you in the next class, or we will move on to the next topic of acceleration and other topics. Thank you very much, everyone.